Hi everybody, how are you? I hope everything is alright. I am Kaushik Das. Today I came back with a new video. From this video we are going to learn Kuder Richardson formula of reliability. But before we start, we need to know some basic concept about Kuder Richardson method. So let's get started. In psychometric, the Kuder Richardson formula KR20, first published in 1937, is a measure of internal consistency reliability. It is developed by Kuder and Richardson. Kuder and Richardson did a series of researches to remove some of the difficulties of the split half method of estimating reliability. They are dissatisfied with split half method of estimating reliability, and therefore they devise their own formulas for estimating the internal consistency of the test. Their formula KR20 and 21 have become very popular and well known, but there are some requirement for the use of KR20 formulas. So what is the requirements? First, all items of the test should be homogeneous. Next, items should be scored either as 1 or 0. That is, all correct answers should be scored as 1 and all incorrect answers should be scored as 0. And next, for KR20 item should not be very much in their indices of difficulty. Okay, let's get started. The formula we will use to find reliability, the formula is KR20 n by n minus 1 minus summation PQ y variance of test score. Here I have already prepared a worksheet. In this worksheet total 10 examinee and 10 items. From here we will calculate reliability by using Kuder Richardson formula. So we can see here some responses. These responses are evaluated and recorded here. Okay, then let's get started. We will proceed step by step. Okay, so step 1, first we have to find out the R. Okay, see what is R. R is the right responses. Okay, let's calculate the right responses. First 10, then 9, 8, 6, 5, 4 and last 4. Okay, the next step is W. Then look what is W. W is wrong responses. Okay, let's find out the wrong responses. First, no wrong responses, that's why it is 0. Next 1, next a 2, then 4, then 6 and last 6 wrong responses. Okay, the next step is calculate P. Then look what is P. Okay, P proportion of correct answer to each item. P is the proportion of correct answer to each item. Let's calculate proportion of correct answers. First 1.0, next 0.9, next 0.9, then 0.8, then 0.6, then 0.6, next 0.6, next 0.5, next 0.4, and last 0.4. Okay, the next step is calculated Q. Then what is Q? Q, proportion of incorrect answer to each item. It's equal to 1 minus P. Okay, so first 0, then 0.1, next 0.1, next 0.2, next 0.4, next 0.4, next 0.4, then 0.5, then 0.6, and last 0.6. The next step is calculate P and Q. Okay, here we multiple the P row and the Q row. Okay, the first 0, second 0.9, next 0.9, next 0.16, next 0.24, next 0.24, next 0.24, next 0.25, next 0.24, and last 0.24. Okay, now we look our formula. There is a summation of PQ. Let's calculate the summation of PQ. Okay, so 0.9 plus 0.9 plus 0.16 plus 0.24 plus 0.24 plus 0.24 plus 0.25 plus 0.24 plus 0.24 equal to summation PQ is 3.41. Now if we go back to our formula, then we see that there is a summation PQ that we have already got. But below we can see the variance of test score, which we have not calculated yet. So our next step is calculate the variance. If we want to calculate the variance, then we first calculate the SD. Okay, the SD formula. So SD 1 by n root over n summation x square minus summation x whole square. There are some requirement, so let's take a look. Okay, capital X raw score or individual responses, x squares of individual responses, and n is the total number of student or exam. Now we first calculate the individual scores. Here we can calculate the only right responses of individual student. So first examining right responses total 7, next 5, then 8, then 9 right responses, then 3, then 7, next 9, then 6, then 4, and last 9. In the next column we squares the individual scores. Okay, then 49, 25, 64, 81, 9, 49, 81, 36, 16, and 81. Now if we get back to our formula, the formula requirement summation x square and summation x. Let's calculate the summation x and the summation x square. So Summation x is 67 and summation x square is 491. So let's start the maths. 1 divided by 10, we know that there is a total 10 examining. Root over 10 into summation x square is 491 minus summation x 67 whole square. Okay, then 1 divided by 10 is 0.1. 10 into 491 is 4910 minus 67 square 4481. So 4910 minus 4481 is 421. Then root over 421. Then 0.1 into root over 421 is 20.51 equal to 2.05. In here we calculate the standard deviation or sigma. Now we calculate the variance. Okay, the variance equal to 2.05 into 2.05 equal to 4.20. Okay, now again we go back to our formula. Then there is small n. So what is small n? Small is the number of items. We know in our worksheet there is a total number of items is 10. Then we find everything. Summation PQ of our summation PQ of 3.41, variance is 4.20, and a number of items is 10. Now we can calculate KR21 formula. Okay, KR21 n minus 1 minus summation PQ by variance of total score. Okay, then 10 minus 1 minus 3.41 divided by 4.20. Okay, then 10 divided by 9, 1 minus 0.81. 10 divided by 9 is 1.11 into 1 minus 81 is 0.19. 1.11 into 0.11 equal to 0.21. Okay, so this is the answer. I hope you enjoyed watching this video. Thank you.